Course 2, Lesson 4, we're going to deal with the number line and sequences. In this lesson, you're going to compare and order numbers on a number line. You're also going to look at the symbols that we use when we compare numbers to each other. We're going to introduce integers and how to add and subtract them on a number line, and then we're going to look at sequences when we have patterns of numbers. This is your list of vocabulary words. You have a document in your coursework that you can pull off so you can learn these. It's important that you know the definitions of each of these so that if on a test they ask you what an origin is, you know that that's 0. You need to be able to know those. Let's take a look at this number line. This is a typical number line. Usually you only deal with the positive numbers, but understand that on a true number line that every number on this side of the line has its opposite on the other side of the line. 0 is never positive or negative. 0 is just a neutral number. It's important that you remember that. They ask you for a list of all the positive numbers, and your list happens to be this right here. This is what you'd only list, these ones right here. You would not list 0, and you would not list the -1 because 0 is neutral and -1 is a negative number. Integers include all of the counting numbers. You remember we had our counting numbers like this here, and that's starting with 1, 2, and 3. And then we went to our whole numbers, which included the 0. Now we're going to go to integers. It's going to include all of those plus the negative numbers also. So integers do not include fractions or any other numbers between those numbers, the whole numbers and the counting numbers. And then when you look at this and see these ellipses right here, that means that this goes on forever in both directions. We compare two numbers by determining whether one is greater than the other or whether the numbers are equal. We place a comparison symbol between the numbers. These are comparison symbols. It can be equal signs, it can be greater than or less than. We write the greater than or less than symbols so that the smaller end points to the numbers that are less. So this small point here always means that the number on this side of this, or where this is pointing to, is less than the number over here. And it doesn't matter what direction it is. This is less than, this is less than. Right? It doesn't matter which direction it's pointing to. Understand that. That can be less than, that can be less than, but the less than's over here and the less than's over here. The greater number is right here and the greater number would be right here. This is a topic of great confusion with a lot of students because they want to think that the direction that the arrow point is what makes the difference. It does make a difference, but it can go both directions. Range these numbers. So look at example 1. I want you to do both of these and then compare them. So pause the video and work them, and then we'll go ahead and look at them. So example 1, you can range those numbers in orders from least to greatest, and in 2, rewrite the expression. The expression is just the words. But you're going to place in that circle, you're going to either place this, or you're going to put in this, or you might put in it equals, or you might put in a not equals. All right. -2, 0, and 1 is the correct order for the number line in example 1, going from left to right. And on this one here, it says rewrite the expression below. -5 is what compared to 3? Well, -5 is less than 3, so we point the arrow towards the -5 because that means less than. Show this addition problem on a number line. What they want you to do here is they want you to go ahead and draw your number line like this. Right? Decide where you're going to start. So if we did, say, 5 plus 1 minus 2, you'd have to come over here and start at 5 right here. Go plus 1 and then come up and go minus 2. So your answer would be 4 in this particular minus 2 would be right there. I'm sorry, it would be 4 in an example I did. That's what you want you to do. Go ahead and do that. Show 3 plus 2 on a number line. So that's what it would look like. You start at go plus 3, start at 0, go plus 3, add another 2, you'd end up at 5. And on this example, if they had subtraction, you just come up and you'd come back however many you need to subtract. So here they want you to do the same thing. They want you to start with 3 and then subtract 5. See if you can draw that. So here they've got, you can go plus 3 and then you're going to subtract 5. So we know that 3 minus a 5 is a negative 2. It's not 5 minus 3. 5 minus 3 would be a positive 2, but that's not what it says. It says 3 minus 5. So negative 2 is our correct answer. It's important you use these number lines to help you until you get the concept of negative numbers versus positive numbers. It can be confusing. So simplify this expression. I want you to subtract 376 minus 840. The first thing I want to ask you, is your answer going to be positive or negative? You should have said that you're going to have a negative answer. Go ahead and work it. See if you can come up with the answer. We see that the results will be negative. We reverse the order of the numbers to perform the subtraction. So we put the 840 on top only because it's easier to subtract than if we were to do 376 minus 840. That's really difficult to do. So we don't do that. We reverse it like this, so we know that, and subtract 376 from 840, but it's not a positive 464. We know that because this negative 840 is greater than 376, that we're going to have a negative answer. It's important that you see that, because let's just go ahead and do this one down here to see what happens. If we do 376 minus 840, watch what happens. That's a 6, that's a 3. Now 3 minus 8, we can't do that. Right? We're stuck. So we can't write it the way it says it. We have to put the 840 on top in order to work the problem. But then it's so important that we remember that this is a negative number and not a positive number. That's the whole trick to learning this. You've got to remember that part right there, or you'll always be getting this wrong. You'll be writing 464, which is not the same thing as negative 464. A sequence is an ordered list of terms that follow a certain pattern or a rule. A list of whole numbers is an example of a sequence. If we wish to list the even or odd numbers, we could do the same thing. Right? We use the ellipses to show that it would go on. These sequences are called arithmetic sequences because the same number is added to each term to find the next term. Thus, the numbers in the sequences are equally spaced on a number line, as you can see down here. So let's look at a few of those. See if we can do them and pick them out and find the patterns. Here's a different sequence, 1, 2, 4, 8, 16. This is called a geometric sequence because each term is multiplied by the same number to find the next term. Terms in these kind of sequences aren't equally spaced, as you can see here. Right? And they'll get further and further apart as they get bigger and bigger. To continue a sequence, we study the sequence to understand its pattern or its rule. Then we can apply the rule to find additional terms in the sequence. In this case here, when we double 1, we get 2. When we double 2, we get 4. When we double 4, we get 8. When we double 8, we get 16. That's our pattern. We're just doubling that number. The first 4 terms of a sequence are shown below. Find the next 3 terms in the sequence. So to just look at this, just looking at that, it's kind of hard to see a pattern. Go ahead and see if you can figure this one out on your own, and then let's go over the solution together. This sequence is neither arithmetic or geometric. We'll describe two solutions, right? We first see that the terms increase. If you look at this, you can see that, can you see there's a pattern here? You can't see the pattern here very easily, but you can see the pattern here, right? That's increasing by 2 each time. So that's our pattern. Once we have that, then it's very easy to continue our sequence. So that's just a little trick you can do rather than just trying to figure it from these numbers alone. Try to write above what the difference is and see if that shows you the pattern. So in this case here, we can see that our next 3 in order is 25, 36, 49. And what would be next? What would be the next one? We'd add 15 to 49 to get our answer, which would be 64 if we had to add one more term. The rule of a certain sequence is k minus 2n. Find the first 4 terms of that sequence. So I like to do this type of thing for these type of things here. 2n and k over here. And I just take a 1, a 2, a 3, and a 4. If I plug a 1 in for n on this first one, I get 2 times 1 is 2. So in my sequence, that would be, the first number would be a 2. And then I work down the list there. Go ahead and see if you can do this yourself. Don't let this get you all confused. It's not that hard. Okay, so we substitute 1, 2, 3, 4 like I did. They didn't use the table like I did. But as you can see, 2 times 2, so 2 times 2 is 4. 2 times 3 is 6. 2 times 4 is 8. And they come up with your sequence 2, 4, 6, and 8. I like to do this. But you don't have to do that if you don't want to. Whatever works for you best. These are your words that you need to practice, or not the words, but the problems that you need to do to get in the door. Work these, send them to me by submitting them in your course, and we'll go over everything tomorrow. If you have any questions, thank you for your time.